Hi everyone, my name is Melanie Nuesch. I'm the head of the high performance computing cluster of the DRFZ Berlin, the German Rheumatism Research Center. Thank you for having me. We are located at the heart of Berlin in the Charité Hospital campus. My goal today is to show you how a traditional biomedical institute focused on translational immunology is building a powerful hybrid HPC strategy that relies on Nextflow for reproducible science. We are not just upgrading old hardware, we are building a completely new computational backbone that is essential for tomorrow's data-driven science. To understand why we need a new computational strategy, you first need to see the assets we are working with at the DRFZ. Our foundation is built on two things: a deep translational immunology mission and world-class automation as well. Our robotics facility sits directly on the Charité clinic site, which is critical because it allows us to receive a patient sample and have it processed in under 20 minutes. This is where the true translational medicine happens. You can see it here in the photo with this yellow arrow is literally crossing the street from our institute. There's the Charité clinic where we take blood samples from patients, and our robotics platform is sitting over there. As you can imagine, this needs a lot of optimization and automation, and we are heavily invested in workflow optimization, working with process engineers even to elevate our standard of automation and data generation up to the level of the industry, or even further, we aim even further of the current standards in pharma industry. This intense automation is paired with our growing biobank that is also an interest of us to keep all these patient samples in an organized manner, providing us with high value patient samples and data that we can use later for other purposes or other institutions can use. These assets are generating massive amounts of unique high dimensional data, as you can imagine, and that's where our challenge begins. So as I said, this world-class automation aim immediately gave us a major computational challenge. The unique essays that we are developing in the robotics facility, so we have some known essays, but we are also developing some new kinds. They generate highly complex, high-dimensional data. We are integrating multi-omics data, everything from proteomics, sequencing, complex 2D and 3D medical imaging and microscopy, spatial microscopy, many derived from the same patient or the same data set. So it's not only one data type that is massive, or many samples is also a massive level of integration and complexity. Even more significantly, we are a center that is actively developing new technologies as well. We are using new types of flow cytometers and microscopes, and also assays, as I mentioned, with our robots. And particularly, we developed a very nice immunoprofiling robotics assay, which means that there are new data types, that there's no software solution available in the market to readily analyze it. So basically, we need to do a lot of new work, metrics, mathematical metrics, code, workflows, both for the new data type and how to integrate it with other data types. So this is the gap I am bridging right now, is where my work as a computational scientist begins, right at the intersection between the robotics facility and the computational world. To move beyond local development and run all this data at the necessary scale, we needed a vast computational solution, as you can imagine. It wasn't just my project also, or my lab. All our scientists, even wet lab biologists, were facing severe bottlenecks handling the volume of multi-omics, microscopy, flow cytometry data, and others. Remember that this institute used to be a more traditional wet lab institute, so people gradually started generating bigger and bigger data without realizing that even they are not bioinformaticians, they actually need more power than they thought. So suddenly, everyone needed a high-performance machine. To solve this sustainably, the answer was a modern high-performance computing cluster with access for everyone. I had already stabilized our institute's old cluster. There was an old cluster, but it was not fitted to our needs. It was a bit outdated. There was only one person managing it, so it was not so scalable. So I got assigned this task because I have expertise in HPC together with my bioinformatics expertise. So I took on this challenge and I was really excited to contribute. But at the same time, in the long term, for maintenance, cost effectiveness, reliability, I made a strategic decision of suggesting to partner with some bigger institution to merge our clusters or that they host our cluster so that I don't have to do a lot of the things alone and I can get a lot of corrections to whatever my design is or my ideas, since I'm not a person that has worked the whole life setting up these high performance computing clusters, even though I have experience and I have a lot of knowledge and skills to take on this task, but still to be part of a team and take it to the next level, make it sustainable, make it like super well done. And for that, we contacted the Zuse Institute in Berlin, which is a supercomputing institute that dedicates to that, to host other institutions' clusters and provide them with the help they need. Also, here in Berlin, we have something called the Brain Network. That is a high-speed network connection across institutes. So we also have a high speed connection in between the two institutes, and our cluster then it sits over there in Zuse. Part of it is very private and isolated for highly sensitive data, and another part it's just a normal HPC for people to play around with. And we also have access to other facilities from the Zuse Institute, which are even more powerful supercomputers. We now have the right science and the right machine, let's say. The missing piece is the human element, how to standardize that. And that's where Nextflow is a big asset. The reality is that our institute has many wet lab scientists who are experts in immunology, but they have varying levels of expertise when it comes to coding and data analysis, or none at all. While they can run a script, if you show them how or provide it, they often cannot confidently judge its underlying methods or guarantee its reproducibility. This situation creates a bottleneck. Our solution is to use Nextflow, which we are leveraging as our standardization and collaboration tool. Our goal is not to have isolated people coding. Our goal is to curate and provide gold standard pipelines. We bring in the best community work like NF Core and train our researchers to use it. So for us, that's better than everyone doing whatever they consider isolated in their desk. And at the same time, it doesn't overwhelm the few bioinformaticians that the Institute has. At the same time, remember that I mentioned we are also developing new technologies, and that comes with new workflows and new pipelines. So we are also considering already writing them in Nextflow so that they can also be shared in the community. This approach gives researchers the power to run their own cutting-edge analysis while ensuring that the methodology, code, and provenance are transparent and validated every single time, which for us it's very important to enforce. This not only standardizes our internal work, but creates pipelines that in the near future, hopefully, can be published and shared back with a wider network of Nextflow, like all of you. With our Nextflow foundation now stable, let's say, that solves a lot of these issues, our focus shifts to enterprise level maturity and sustainability. As I said, for us, it's very important to standardize all of this, to train the people, to give support, and it's already reaching like an enterprise level, not such a normal academic level, I would say. So we need to ensure that this platform can be maintained reliably for the next decade, let's say. So our first strategic move is to explore certain solutions like the Sequera platform that can provide the necessary management, monitoring, professional oversight required for a production level facility like we want to have, especially with the robotics platform specifically and the high performance computing platform of our institute. But we also have other platforms as well that will be suited for this scaling up. Again, to ensure gold standard pipelines, but also to have certain level of comfort and customer service and support, let's say, beyond just installing the pipelines and running the pipelines. Not everyone, as I said, has certain level of programming to do this fast, competitive enough. At the same time, of course, we are growing the high performance computing team and the people, the admins, the people that will be involved in providing support from the DRFZ side as well. Another thing that is very important to mention is that our entire platform, from the Zuse Institute partnership to the Nextflow standardizations, all of these things, they are built with an ultimate goal in mind, that is also to leverage artificial intelligence and to take the knowledge of the data we have to the next level. To do this effectively, we are establishing a central data lake foundation as well. This is where all our institutional knowledge, our custom assay data, and our collective multi-omics results will reside, but also we will leverage AI as well to do other level of analysis, not just to keep it there. By standardizing our pipelines with Nextflow, we ensure that the data entering the data lake is fair, follows the FAIR principles, and it's clean, which is the non-negotiable requirement for training a robust AI model. So this capability is how we truly squeeze the juice out of all our research. We move beyond simple analysis to building predictive models and neural networks that can find hidden patterns in our immunology and patient data. Our goal is simple then, to transform our data into a strategic asset that fuels our next generation of discovery. This leads us directly to the technical challenge of validating these models quickly and reliably as well. So as an example from the Nextflow community, connecting with what I was just saying, our ultimate goal is to move into machine learning neural networks to truly squeeze the juice out of our data. This slide shows a very interesting example. There's a Nextflow pipeline, I don't know if many of you have used it before, designed to automatize predictive modeling, which is very useful for people like us that have this interest. We need to know which model is best for a given task many times. Or let's say it would also be nice if people not only apply a model, but also compare the performance and make a educated selection. So this pipeline lets us test several algorithms at once. You can see the acronyms there. So dummy, XGBoost, random forest, multi-layer perceptron, regressions. And this is nice because of two things. So one is the speed. It allows to run all these models in parallel across the cluster, getting results faster. And the second thing is validation. With this kind of Nextflow pipelines, it guarantees that every comparison happens inside a standardized reproducible container. This means that the predictive model we select for our patient data is valid and it's trustworthy. So I'm looking forward to explore more of this machine learning and neural networks application of Nextflow pipelines and even do some work there to develop new ones if possible. So to conclude, this is hopefully a successful modernization story. We started in a more traditional legacy IT and wet lab workflows and data silos, and now we move to a fully operational high performance cluster platform, robotics platform, and a lot of other nice things that our institute has to offer. And of course, Nextflow is a very key central point of this achievement. So this project is a testament of how traditional biomedical science can be future-proofed, let's say. We are building a sustainable system that gives every scientist from the robotics lab to a computational desk the power to find complex translational insights. We want to keep this momentum going. We want to hear from you. If anyone has anything to say or want to connect, please send me an email. You can look for me on LinkedIn or X. And thank you very much for your time. I look forward to your questions.